very good morning, everyone. Any doubts from yesterday's session? You have not seen yet. Take it. It is uploaded in the website. Those who missed the live or offline class, you can watch the recorded session. Okay. And if you get any doubt, you can ask me. And I have also given one question for answer writing in yesterday's session itself. So now we will continue our discussion. See, let's do a quick recap of what we have covered so far. Tell me, in the last session, what did we discuss? After covering, see, last session we have covered in the lecture number 3, we have covered theories of geomorphology. So some of the theories, what are the theories that we have seen? Continental drift theory, then convectional currents theory, then sea floor spreading theory, then finally plate tectonic theory. These are all the theories that we have covered. Now, this has given us some idea about what are the various physical phenomena that happens and what kind of landforms are created, what are the different endogenic forces. Then we slowly shifted our focus towards the exogenic forces. Under these exogenic forces, in the last session we have covered earth movements, right? This is what we have seen. In earth movements also, we have covered two types of movements. The movements which are caused due to endogenic forces, right? Under which we have earlier covered endogenic forces. They cause sudden movement. And again, these have been classified into sudden movements and slow movements. Slow movements we have not covered yet. Today we will cover one of these slow movements under the topic of erosion. When the mountain building process happens, how does that slow foldings and faultings lead to formation of different mountains? But we have covered sudden movements such as earthquakes and volcanoes. Okay, this is what we have seen. There seems to be some sort of lagging here. Those who are in the live, tell me, is that going smooth? Is there any lagging? Now it is clear here also. Okay. Then slow movements we will discuss it today. Then we have seen some movements due to exogenic forces. Okay. Under this we have seen 4 types of movements particularly. One is weathering. We understood weathering, different types of weathering. Tell me, what are the types of weathering? Physical weathering, biological and chemical weathering. And within them we have seen some of the processes of weathering, right? With the examples. Then we have seen another topic called mass movements. Under this also we have seen various movements ranging from landslides, earth flow, solifluction, soil creep, rock flow, avalanche, etc. We have covered that. Okay, mud flow, etc. Then here itself we have 2 more exogenic forces causing movements. That is, one is your erosion and transportation. This we have not discussed yet. Transportation. And there is another one, that is deposition. These two we did not discuss it yet. We will discuss them just before your different landforms. Particularly when we begin fluvial landforms, the landforms created by a running water. Then I'll explain the concept of erosion, transportation, deposition, different types of erosions, and deposition, what it leads to, what kind of landforms are created. So we have covered this. Now our focus, this also, sudden movements we have covered already. Our focus is slowly shifting to these slow movements now. Then later we will cover them. Okay, nothing, we are going to leave nothing. Now let us take these slow movements under which mountain building process. Orogeny is the mountain building process. Mountains doesn't erupt in one day. It takes thousands and thousands of years, and every time when there is a slow folding or slow faulting, that results in the formation of the mountain. So in this session, our learning objective is, first we will understand the mountain building process or formation of the mountains. Then we will see what are the different types of mountains and their distribution, where they are distributed, how they are distributed, any particular reason for their such sort of distribution, and then finally we will look at the significance of such mountains. Getting it? So this is our learning objective of today's session, and here we will be like mains orientation, this significance and distribution. The reason for such a distribution is important. Every time they will be asking some questions related to the distribution of different types of mountains, fold mountains, block mountains, volcanic mountains, such sort of things. Okay. So let us begin with the first and foremost, the mountain building process or formation. See, we are familiar with some sort of mountain ranges of the world. If you notice here, the stretches, the patches that are being shown here are some of the mountain ranges in the world. What is a range? A range is a continuous series of mountains. And if you notice here on the western stretches of Northern America, that is both Canada and USC, you can find a series of mountains called Rockies. Then you have Andes. On the eastern side you have Appalachians. Then Atlas, Atlai, Alps, Urals, and Himalayas, Ghats, Eastern and Eastern Ghats, Great Dividing Range, Drakensberg. These are all some of the important ranges. Now, our main motive is how they are formed and why they are distributed in these locations. Is there any particular cause behind it? Is there any particular factor behind it? That is what we are going to learn. First and foremost, what is the meaning of orogeny? In geology, orogeny means the mountain building process or the process in which a section of the earth, we know earth composes of different layers, a sedimentary strata. So when these layers of the earth are subjected to different forces, both due to endogenic, majority of them are due to endogenic, and minority, like some mountains, are also due to exogenic forces. We call them as residual mountains. Later we will see them. Okay. But majority of them are endogenic reasons. Now, due to these endogenic forces, when the crustal block is being pushed together, that means there is a compressional force. When there is a compressional force, or when there is tensile force. Tensile means खींचना, compress means आगे push करना. So when there are such sort of compressional forces or tensile forces due to plate tectonic movements. So we have seen various tectonic interactions are there, different plates. There can be convergence, there can be divergence, there can be transformation, there can be eruption of the material, volcanic eruptions. So in those processes what happens is there is upward movement of them, and as a result of it some deformation will happen and you may get some compressions to form mountain ranges. It may be due to compression, or it may be due to tensile faulting, or it may be due to deposition of the volcanic material. Mid-oceanic ridges we have studied earlier. They are nothing but series of mountains within the oceans. And how did they form? Because of the deposition of continuous lava again and again, right? So this is how we get them. And they vary in their structure. Some of them are conical in shape, some of them are very random, some of them are round. Some of them have like sharp edges. So in their structure, in their height, some of them are as tall as 8,000 meters also. Some of them are as low as 800 meters, right? So in their height, in their formation and certain features. So we will try to explore what are the different types and formations and structures, etc. Now with this little bit of introduction, let us enter into the types of mountains and then we will see the formation process. Now these mountains, on the basis of the location, we can divide them into like those which are, say, oceanic mountains, inland mountains and coastal mountains. Look at them. Here, there are some mountains which are formed here in the mid-oceanic ridge. They are completely submerged within the oceans. Such kind of mountains we call them as oceanic mountains. Sometimes we also call them as sea mounts. Sea mounts, goats. This we will see it in the oceanic relief topic. So they are oceanic mountains. Now there are some inland mountains. So interior of the continents, for example, Himalayas, Karakoram, Atlas Mountains, Aral Mountains. These are all some of the examples of inland mountains. And there are some mountains which are at the margins of the ocean and continent. For example, these Rockies, Andes, Appalachian Mountains, Drakensberg, Great Dividing Range, Atlas, Alps, etc. Scandinavian. You can say Western Ghats as well. Okay. This is due to faulting of it. Okay. When it broke, see, we know that Indian plate was part of the southern land, Gondwana land. It broke and it has gone. When it has broken, so there is that faulting. And that's the reason why you can see this coast, western coast is highly inundated coast. It is not a emergent coast, rather it is a submergent coast. There is very good inundation, right? So on the basis of the location, you can divide them into oceanic mountains, inland mountains and coastal mountains. This classification is not so important, only it is telling you the location, no other information. But on the basis of the formation or mode of origin, if you go, again they can be divided into fold mountains, block mountains, volcanic mountains and residual mountains. So this is our main focus. Apart from that, they can also be divided based on the age of formation, at what time they got formed. On the basis of it also we can divide them. For example, Precambrian mountains, Caledonian mountains, Hercynian mountains, these are all based on the age of formation. But for the examination perspective, this is also not important for us. Our major focus should be on the mode of origin. That's the reason why we will be elaborating on these types of mountains. Now, if you look at the image of these mountains, they look somehow similar to this. Now here, these are the mountain ranges which are formed due to folding. And you can see the crustal plates are the sedimentary rocks of this strata being folded here. You can see those fold lines as well here. Look at that. Is it visible? Yes. Here. So folding has been happened, and this folding continued and it has given a series of mountains. Here if you see, series of mountain range has been created. These are fold mountains. Again, they can be further divided. We will see it in the next section. Then there is block mountains. See, for example, here you find a valley. This one. This is a rift valley. How it got formed? When this crustal block faulted, a portion of it subducted, and that has given you the rift valley. And opposite में जो portion बचा हुआ है, which is looking like a tall elevated portion, that's what we call it as block mountain. Block mountain. Horst and Graben करके भी बोलते हैं इनको. Then comes volcanic mountain. See, there is a confusion. People generally confuse that the mountain, whatever that gives the magma, is a volcanic mountain. It's not so. See, there are some mountains which are fold mountains, but they are associated with volcanism. Meaning, see, how did volcanic mountain formed? When there is a continuous eruption of volcanic material that gets accumulated, that gives you a steep structure. Then you say that is a volcanic mountain. But there are some fold mountains, particularly at the margins of the continental and oceanic crust. We have seen earlier, when there is a convergence of continental and oceanic crust subducts. That gives rise to formation of the magma, and this magma will try to erupt here. We were discussing about the fold mountains associated with volcanism. That was the concept I was explaining, because we were discussing about types of mountains, particularly volcanic mountains. So volcanic mountain is formed by the accumulation of the material which got ejected from the volcano. But there are some fold mountains which are also associated with volcanism, particularly at the margins of the continent and the ocean, where the oceanic plate subducts and it creates magma, and this convergence creates your fold mountains here, and from those fold mountains you can have the eruption of magma. right? So those are different. They are fold mountains associated with volcanism. Okay, so that is another type. Then there is a peculiar type of the mountain which is called residual mountain. So what is the meaning of residue? Residue means something which is left over. Yeah. So how these mountains are formed? When exogenic forces, see till here, folding, faulting, and then volcanic eruptions are the causes. All of them are endogenic reasons. But here, when the agents of weathering and erosion works on the surface of the earth, some material will be denuded, but some core portion of the earth will be left behind. जब एरोड कर रहा है, वेदरिंग कर रहा है, कुछ पोर्शंस ऐसे होता है कि काफी रेजिस्टेंट है वेदरिंग प्रोसेस का, देन इट विल स्टे स्टैंड अलोन. सो दैट पोर्शन विल लुक लाइक उसके साथ साथ जो भी मटेरियल है दैट विल बी रिमूव्ड एंड इट बिकम्स प्लेन, एंड ये वाला पोर्शन जो है जो काफी स्ट्रांग है, काफी रेजिस्टेंट है, दैट इज गोइंग टू स्टैंड अलोन, and that will give you the residual mountain. So these are the 4 varieties. Now what we will do is we'll take up each of them and see how the process is and the process of formation is there for each of them. So beginning with the fold mountains, we are familiar with the process where we have discussed the plate tectonic theory. So when does the fold mountains form? When there is a convergent boundary. Convergent boundary are destructive edges created between two plates. It can be continental or it can be continental and oceanic plates. When the continental plates converge, what happens? The crustal blocks, see, let's say this is the crust of the earth. Crustal plate, tectonic plate, when it is being pushed due to convectional currents, of course it will be compressed, it will be put to compression. As a result of these compressional forces, it starts slowly bending, and after a time further there is a continuous compression. This bending becomes little steeper. And when this process happens for a very long period of time, what happens? Then there is a clear cut formation of the upward and downward foldings, and here we use the word anticline and syncline. See, in waves we were using the words crust and trough. In the similar manner, here we use the words anticline and syncline. Take a simple terminological difference, but the mechanism is same, and here the foldings are created due to compressional forces. See, when the compressive forces due to the plate tectonic movements, convergence particularly happens, then there is up and down folds in the earth crust. These up and down folds are called anticlines and synclines respectively. So anticline is a inverted U-shaped one, whereas syncline is a U-shaped one. Value जैसे, ठीक है. And based on the folding, once again we can classify these fold mountains into symmetric, asymmetric. See, overfolds are there, napes are there. These are all different types of the fold mountains based on the folding. See, यहाँ पर look at this. Till here the folding is symmetric. Symmetric means when you take a vertical plane line, both sides are like equal, almost equal, like a mirror image. You can see it here. This is the symmetric folding till here. But look at this fold. Here, this is the vertical line, but the fold has slightly deviated from the vertical line. So it is a asymmetrical folding. When does this happen? When the continuous compression is further happening, and if there is a drifting of that material or drifting of the plate, then there is a asymmetric folding. Further drifting or further compression may lead to overfolds. Overfold means when suppose say symmetrical folding, I am the vertical line, so there is a symmetry both side. If I slightly deviate from the vertical fold, then this is asymmetrical folding. If there is further deviation, this is overfold from the middle axis. But if the top portion is deviated to a long distance from its vertical axis, then we call it as recombinant fold. And further recombinant, like कब तक, जितना ज्यादा कहां तक हो सकता है, एक टाइम पे ऐसे आएगा कि ये पोर्शन जो है ये टूट भी सकता है, टूट पर वो क्या होगा, उसके ऊपर फिर गिर जाएगा, यहां पर गिर के it can give that kind of another look, that is called an epi. ठीक है, so let's have a look at this. See here with this diagram you can see there is a symmetry here. Till here there is a symmetry. So here you can look at the mountain ranges are also, they are parallel, they are symmetrical, even the cones are okay, fine. Even this line is also, sync line is also giving a valley kind of thing, and here is also symmetry. But look at this, here it is vertically, मतलब दोनों side पे ठीक है. But here there is a slide, this is the vertical line, but the central axis is slightly deviated. So you got the asymmetrical foldings. And asymmetrical foldings further, when they have folded, you are getting the overfolds. Look at this brick wala line जो है ना, इसको देखो पता चल जाएगा. So we are getting overfolds and recombinant folds. So when there is, यहाँ पर भी ये जो black वाला line देखो, clarity आएगा. This is overfold, this is recombinant, and when this further happens, this recombinant fold may fall onto the other layer, and that is called a nappe. And here it looks like it is a detached fold from the center, and it appears that it has moved to a distance from its central axis. That is a nappe. Once it was asked in your prelims. Right? So these are all the different types based on the folding. Now the method of formation is very simple. See, let's say this is the sedimentary layer, the crustal block. When it is subjected to the compressional forces due to convergence, tectonical interactions, initially there will be these folds, and when this is further being pushed, then you have recombinant folds and all. As a result of it, here you get series of parallel mountain ranges. Take example of Himalayas. There are parallel lines in NCERT also. We have seen 3 parallel things are there, like Greater Himalayas, Shivalik Hills, then Himadri Himalayas. So you have seen. Okay. So same goes here as well, and this is the simple formation method. Understood? Now, based on the folding, simple folding and complex folding, and you get symmetrical and asymmetrical overfolds and recombinant. Based on age, fold mountains can again divide into old fold mountains, young fold mountains. Old in longer times, like it goes back. Young, relatively lesser. For example, Himalayas got formed around 10 million years ago. Like when there is a collision of your Indian plate with the Eurasian plate. So such later ones are called generally young fold mountains. So this is based on the age. Now, what is the difference? Yes? Some doubt? No. Okay. So what is the difference between these young fold mountains and old fold mountains? How can we perceive the differences? Sabse first, in the relief itself, matlab how they look. Generally, old fold mountains have been formed at a very long period of time. Since then, they have been subjected to various exogenic forces. That means wind, water, biological activity, all these are continuously eroding them, denuding them. As a result, they become slightly round. They are not show sharp edges. So ruggedness in them is slightly less, and they appear as round. Take the example of Aravalli mountains. They are more or less like round shaped ones. But the young fold mountains will be rugged, meaning they will be very random. Look at Himalayan mountains. I have shown in one of the videos. They have sharp edges, conical peaks. That kind of ruggedness is there, and mounting them is also a difficult task. So this is first indication. Second indication is, see, generally fold mountains are the loftiest mountains in the world because they are formed due to tectonic activity of folding, compressional forces, which has uplifted this material. But if it is a old fold mountain, since it has been exposed to the erosional activity for a very long period of time, so उसका height थोड़ा कम हो जाता है. But young fold mountain है तो वहां पर अभी भी drift चल रहा है and there is still compression, and as a result of that continuous compression their height is slowly further increasing. So in height you can see young fold mountains are very lofty, as high as 6,000 meters to 8,000 meters also, whereas the old fold mountains are low in height. Further, peaks, if you look at the important and lofty peaks, they will be less in old fold mountains, very less number of peaks, and that too not so high. But in case of young fold mountains, you see high pyramidal or conical peaks. Take example of Himalayas. I'll show you later. There are so many peaks. Everest, Makalu, K2, Kanchenjunga, Annapurna, all of them. They are all very great peaks in Himalayas, right? So these are the differences between young fold mountains and old fold mountains. If you look at the example, the best example in India for old fold mountains is Aravalis, and young fold mountains is Himalayas. This is just an example. You can find more and more examples of both old fold mountains, and rocky Andes are also young fold mountains, right? Now, what are the characteristics, overall characteristics of the fold mountains? See, in the formation, most of them are youngest. They formed in the recent times, maybe 50 million years ago, 100 million years ago, 200 million years ago. So they are the youngest mountains of the earth. First characteristic. Second, they extend for great lengths. Why? Because they are formed due to this convergence, and convergence happens along the margin of entire continental plates, and these tectonic plates are of very great sizes. Take the example of North America, which is a very big plate. South America, big plate. Now, North American plate and South American plate both converged with your Pacific plate. That's the reason why along the margin you got the fold mountains, which we call Rockies and Andes respectively. And look at the length of them. It's very high. Or you take the example of Himalayas. Generally, the length of Himalayas is 2,400 kilometers from Kashmir to Arunachal Pradesh. Even it extends in the Purvanchal also. But if you see the weight of them, it varies like 50 meters to 400 meters in case of Himalayas. Why the width varies? The width depends upon the compressional force. More the compression, more will be the width. Lesser the compression, lesser will be the width. But length will be along the entire margin. That is the reason why they have very great lengths, whereas their width is considerably very less, even not even 1/4 of the length. Then comes, they are found generally along the continental margins facing the oceans. Now, इस पे भी क्वेश्चन आया था, why most of the fold mountains or mountain ranges are found or distributed along the continental margins?
Because that is the
convergence. The zone of convergence is there. That is the reason why you find them at the margins of the tectonic plates, right? So this is another characteristic of them. Then there is a recurrent seismicity associated with them. Obviously, when there are plate interactions and seismically they are still active, that means the plates are still in movement. So plate movements are still happening, that induces some sort of seismicity. That's the reason why these mountains, fold mountains, are associated with continuous like earthquakes and in some areas volcanic activity as well. Next comes, yes, volcanic activity. Not all the cases, but wherever the continental crust plus oceanic crust convergence is there, here the fold mountains are formed. They are also associated with volcanism. But please understand, these are not volcanic mountains. They are the mountains associated with volcanic activity, volcanism, right? They are not formed due to volcanic activity. They are formed later volcanic activity developed in them. Right? So this is another feature or characteristic of them. Then next, they are the most widespread and also most important mountain ranges. We will see the significance. Widespread because continental har margin pe you get them, and they contain rich mineral resources because their core granitic rock, and there are many minerals, iron, tin, gold, copper. Such important commercial minerals are found in them. So economically also they are very important. Plus they are also important for the tourism and many rivers. See, majority of the rivers, they have their birthplaces in those fold mountains. Right? These are all the characteristics.